in this video. I'm going to talk you through what Pearson's correlation coefficient is and how you can set up your own personal spreadsheet using example data, so that when it comes to your scientific investigation, or if you have data elsewhere, okay, you can instantly input your own data into the spreadsheet and it should automatically update, okay, as long as it's done properly. So Pearson's correlation coefficient is very similar to the Spearman rank correlation, okay, but instead of looking for associations between different measurements made from the same sample, you're going to look for associations between measurements of two variables, okay. So it tells you if there is a significant correlation between two measured variables, for instance x and y, okay. From GCSE you may remember this. Instead of calling it coefficient, you may know it by a line of best fit, okay. So if that correlation is negative, if it's positive, okay, you can only do this correlation if it's between two measured variables and the data must show normal distribution, okay. So what exactly is the coefficient? So coefficient R is a value between -1 and +1, and it will tell you if there is a correlation, if there is if there is difference between x and y, okay. So when there is no correlation at all, R will be equal to 0. So there is no significant correlation, okay, there is no pattern. Minus usually tends to mean negative, okay, and as you can see, from 0 to -1 shows a stronger correlation as you get closer to -1. Same goes for if you go towards +1, okay. Instead of them being scattered randomly, slowly they start to form a line until +1, where it is in a straight line, right? So here's an example. Is there a significant correlation between an animal's nose to tail length and its body mass? Okay, so here's a set of data that I'm going to be using, and I'm going to perform a statistical test on this data to see if we can find a significant correlation, okay. If yes, then is the correlation positive? And if the correlation is positive, does a long tail mean larger mass? Okay. So this is the equation. This is the equation. Looks nasty, I know, it looks horrible. But don't worry, because we're going to be doing this in Excel, we're going to break it down, okay. So we're going to break it down into small bits that's manageable for not only you to understand, but it will be easier for the program to understand and to see where you've gone wrong if you've gone wrong. Because trust me, I have done these kinds of statistical tests before on paper using a scientific calculator, and if you manage to fudge up one number or forget to bracket somewhere, it is a nightmare. So I tend to use Excel myself because it's easier to see where you've gone wrong and compare with, say, like the person next to you or something. Okay. So a few things that you need to know. R will always be a number between -1 and +1. If it's not in between those numbers, then you've definitely done something wrong somewhere. And this number will be compared to those in a table of critical values, right? And that's using n minus 2. So n is the number of values of x and y. Okay, and then -2 will give you degrees of freedom. Now, why do we need a critical value? The critical value is going to allow us to accept or reject the null hypothesis. So in this case, the null hypothesis, HO, means there is no statistically significant correlation between length and body mass. Okay, HO is a null hypothesis. There is no significant difference. Okay, so the critical value is going to tell us if we should accept the null hypothesis, that there is no significant difference, or if we're going to reject it. By rejecting it, we ultimately accept HA. HA means that there is a statistical significant difference, a correlation, between length and body mass. Okay. So in what case do you reject the null hypothesis? So you reject the null hypothesis if your R value exceeds the critical value. So if your R value is bigger than the critical value, then you can reject the null hypothesis. If it is lower, then you have to accept the null hypothesis. Okay, let us not forget, a negative value for R implies a negative correlation. A positive value for R implies a positive correlation. Okay, moving on. So construct the following results table. Okay, so animal. And that's n equals 7. So we have 7 animals that have been measured. Mass is going to be our x. Length is going to be the y. Okay. 1, 2. Mass is 1, 4, 3, 4, 8, 9, 8. 2, 5, 8, 12, 14, 19, 22. Okay. We need total, and we're going to need the mean down here as well. And on the top, you're going to need x squared, y squared, and then x times y. Okay. To get this little hat here, this bit, that bit. Okay, all you have to do is shift 6 to get that little hat if you're on a UK keyboard. Okay, so in order to do the total, you're going to press equals. When you type equals into Excel, you're going to tell the cell to calculate something. Okay, so I'm going to put equals and then sum. Sum means it adds all the numbers together in a range of cells. So sum open bracket. You're going to click and drag. Okay. So I've selected B2 to B8. I'm going to close the bracket and then press enter. So that is the sum of all these added together. I'm going to do the same for the next one. Close the bracket. Right. So the mean then, for the mean, you're going to press equals. Okay, and all you need is the total divided by the number of it, so how many animals there are, how many values you have. So that's 7. Enter. 5.29. Yep, that's correct. Equals that one divided by that one. Okay. Now, let's focus on this. Okay, so we're going to square the x values one by one. So you can click equals, select that one. You do the hat, which is shift 6, and then 2 to square it. If you need to cube it, you'd put 3, and then 4 and 4, so on and so forth. Okay. And then you're going to select that. Because the formula is going to be copied for all of these, okay, all you can do is, you see this little green square, a square within a rectangle, yeah. Now if you hover over it, the plus becomes black. You're going to click and you're going to drag, and that is automatically squared all of these numbers. Yeah. Okay. I'm going to do the same for the y's. Oops. Hat 2. There you go. Right, now x times y. So a lot of my students confuse themselves here. So it's not x squared times xy, x squared times y squared. It's these numbers. It's x times y. So x and then times, that's shift A, or on your numpad. If you've got a numpad, it's the star, times by that one. And again, it's the same formula, so just going to click and drag. Okay. And there we are. Now we need the totals of all of them. Okay, you don't need to do the mean for every one of them, you just need the totals. So equals sum, open the bracket, click and drag, there you go. So he's going to do sum all along here. There we go. Right. So I'm just going to color coordinate this just so it's easier to see where the values are coming from. I apologize if you can't see this. I apologize if you can hear that. Okay. So back to this equation. Okay. So this nasty long equation. Oh, hello. Yeah, this one. Right. So it's easier for you to break this down into top and bottom. Okay. So R equals, and I'm going to put top, bottom. Okay. So your top, I'm going to press equals. Alright. Select XY. That's the sum of XY. Okay. Minus. Open the bracket again. 37x times 82. That's y. Close the bracket. Divide that by 7. Close the bracket again. Okay. Now, note that the bottom is square rooted, but first what I'm going to do is I'm going to work this out first before I square root it. Okay. I'm just going to fill this in a nice bright yellow because that's the final answer that we want. And that's the final answer we want. And so the bottom equals x squared. Okay. In fact, no. Open the bracket. Sorry. Open the bracket. X squared minus. Open the bracket. Open the bracket again. I'm going to square it. So that's x squared. Close the bracket. Divide by 7. Yeah. Close the bracket again. And close the bracket again. Times. Open the bracket. Y squared minus. Open the bracket. Open the bracket again. Y. And that's squared. Divide by 7. Close the bracket. Close the bracket. Okay. There we go, a nice big number. Finally, SQRT. Open the bracket. Select that cell. Close the bracket. And there you go. Okay. Just going to double check. So that's 7 actually. Used to be that. There we go. So you see, you break it down further, you can see where you've gone wrong if you've done anything wrong, okay? Oops. There we go. Right, I'm just going to check the answers. See, we've got 119.75. Yep. Yep. So they could be just round to error anyways. Down to error. Right, so R equals, start it, equals top divided by the bottom, enter. Is that what we've got? Is that the answer? Yay! And that is it. That is your working spreadsheet. Okay. Okay. This is your working spreadsheet. This is the final answer that you've got. This is your R value. Okay. Now, note this value is a positive value. There is no negative in front of it. There is a positive value, which means the correlation is positive, or that any correlation is positive, really. Okay. Your degrees of freedom is going to be 5, because n minus 2, so 7 minus 2 is 5. Yeah. So when you look for a critical value, your degrees of freedom is 5, and your critical value, you need to look for p equals 0.05. Okay, that gives you a 95% confidence. Yeah, shows that you're 95% confident that what you have calculated is correct. Okay. Now the critical value for that degrees of freedom for that probability, the critical value is 7.5. So, does our value exceed the critical value? Yes, it does. So therefore, we reject the null hypothesis. We can conclude that there is a significant positive correlation between the length of an animal and its body mass. In simple terms, a long tail is associated with a larger body mass. Okay. So now when you try and change these, the number will change. So let's just try it. So instead of 12, let's say it's 20. There you go, it's changed. and that is your working Excel spreadsheet for Pearson correlation coefficient statistical test. See you later.